Welcome to the geography series of lectures. Today, dear students of physical geography, I'll be talking to you about the earthquakes. This particular topic also has about 5 subunits, namely Introduction to Earthquakes as an Important Endogenic Force, the definition and nature of earthquakes, causes of earthquakes, distribution of earthquakes in the world with special reference to India, and tsunamis and earthquakes as environmental hazards. Now let me come to the details of number 1. Planet Earth in its crustal zones experiences violent forces which are collectively known as endogenic forces. They are emanating from below the surface of the earth. 2 of them are earthquakes and volcanoes. In many cases, volcanoes precede the earthquakes and often they are associated with each other. These are destructive forces. Particularly earthquakes bring not only surface changes and also cause immense damage and destruction to property and lives. When earthquakes occur on ocean floor, they lead to tsunamis. They are mammoth destructive sea waves, bring loss to lives and properties. As a last aspect of this episode, we will be knowing them in detail. Both earthquakes and volcanoes are considered as environmental hazards. Their scientific study in physical geography and other branches of earth sciences assume importance. In fact, a branch of earth science, seismology, goes into furthermore details of the study of the earthquakes. Countries like Japan, New Zealand, USA have highly advanced research institutes of seismology and they are constantly monitoring these potential zones of earthquakes. Though peninsular India is relatively free from violent earthquakes, North Indian Himalayan belt is prone for high magnitude earthquakes frequently. In fact, in this episode on earthquakes in their distribution across the world, we will be knowing more about these aspects in our region. The growth of scientific investigations into these endogenic forces through geology, geophysics, seismology, and management of tsunamis in recent years now many is quite successful in their regions of occurrence rather than when they are going to happen. Earthquake is a phenomenon of the Earth's crust and it is a violent tremor caused by volcanic actions or the movements of the earth crust. An earthquake is a major destruction of the powers of tectonic forces caused by endogenic thermal conditions of the interior of the earth. The earthquake is a form of energy wave motion transmitted to the surface layer of the earth in widening circles from a point of sudden energy released. It's also known as focused. In other words, earthquake is a vibration or the oscillations of the surface of the earth caused by the transient disturbance of the elastic or gravitational equilibrium of the rocks beneath the earth's surface. The places of the origin of the earthquake is called focus. Now, if you carefully see figure number 1, you can understand, see there is a focus down below the earth crust and see above that you have epicenter and how the simple fracture of the earth crust leads to sometimes formation of earthquakes which has a focus and also an epicenter. This focus always lies in the earth crust, but its depth varies. The deepest earthquake may have its focus at a depth of about 700 kilometers below the surface of the earth. But some of the earthquakes, as they have their focus around 20 to 30 kilometers deep, most of the earthquakes, they belong to this kind of shallow focused earthquake zones, you see. The place on the ground surface which is perpendicular to the focus recording the seismic waves for the first time is called the epicenter. The waves generated by the earthquakes are called seismic waves, which are recorded by an instrument called seismograph. In order to have a clear view of the seismograph, you can see figure number 2. It has a platform made up of very sensitive metal. There is a bent bar. Onto that, there is a string. At the end of the string, you see a pendulum. Pendulum has a needle, and that pendulum ultimately oscillates according to the vibrations of the earth. Then ultimately, this is recorded on a graph. There are 3 types of seismic waves generated by earthquakes, and they are primary or P waves. They have shortest wavelength and high frequency. They are longitudinal waves which pass through the solid crust of the mantle, but also through the liquid part of the core of the earth. Now let me come to the second type of waves which are generated in during the earthquakes. They are known as secondary waves. They are also known as S waves, have the shortest wavelength and high frequency. These are transverse waves pass through all the solid part of the earth, but not the liquid part of the core of the earth. Third type of earthquake waves are known as L waves. They are also known as surface waves. L waves have a long wavelength, low frequency, and confined to the skin of the earth's crust, that is the outermost crust, thereby causing most of the earthquake's structural damages. These are further subdivided into Q waves, in which there is a strong horizontal motion perpendicular to the direction of the propagation of the waves. They are also known as R waves or Rayleigh waves, in which there is a strong vertical stones at right angle to the direction of the waves propagation. Now let me come to, that is the measurements aspect of the earthquakes. There are 2 main methods of measuring the strengths of the earthquakes, and they are Richter scale and also Macaulay scale. In 1935, C.F. Richter, an American seismologist, devised a formula for calculating the strength of an earthquake and the instrument recording their magnitude. This is related to the total amount of energy stored in the rock under the stress and released during an earthquake shock by the initial rock fracture at the origin of the focus. The scale is open-ended, ranging from 0 to 8.9, which is the largest recorded earthquake in Chile, and which produced energy equivalent to 10 raised to 27.2 ergs. The second important scale, which is used in the measurement of the earthquakes but not as popular as the Richter scale, is Macaulay scale. The Macaulay scale uses observations of an earthquake effects at a point on the Earth's surface to assess its intensity. Remember, Richter scale uses to explain or to measure the magnitude of the earthquakes, whereas Macaulay scale measures the intensity. Earthquakes in general are caused mainly due to the disequilibrium in any point of the Earth's crust. Major earthquakes in the world are caused by the natural forces, and also some minor earthquakes happen due to human-induced earthquakes. Now coming to the natural forces, very important the phenomena which leads to earthquake, as we already know by this time, is volcanicity or volcanic activity. Volcanicity is considered to be a major cause of the earthquakes. The explosive, violent, gases during the process of volcanicity try to escape upward, and hence they push the crustal surface from below the great force, and thus is caused severe earthquake tremors of high magnitude. For example, the violent eruptions of Krakatoa in East Indies between Java and Sumatra caused such a severe earthquakes, destroyed 3 islands, killed 36,000 people, and also caused tsunamis something like 30 to 40 meters high, which were felt near Cape Horn, about 12,800 kilometers away. Now, another very important natural cause of earthquake, which is also associated with the volcanoes but preceded, is the plate tectonics. One of the major causes of the earthquakes is plate tectonics, where both continental crust and oceanic crust either move apart, where we see constructive plate margins, or they move over or collide or slide past over one another. That point is known as the destructive plate margin or the boundary. Particularly in the later type, that means in the destructive plate boundaries or the plate margins, earthquakes of large magnitude occur. Major tectonic events associated with these plates boundaries are ruptures and faults along the constructive boundaries, faulting and folding along the destructive plate boundaries, transform faults along constructive plate boundaries. All sorts of disequilibriums are caused due to different types of plate motions. Another very important natural cause, which is very closely associated with these phenomena, is faulting and elastic rebound phenomenon. The horizontal and vertical movements caused by endogenic forces result in the formation of faults, and which in turn cause isostatic disequilibrium in the crustal rocks, which ultimately cause earthquakes. According to elastic rebound theory by H.F. Reed, the underground rocks are like rubber and expand and stretch when pulled. The stretching and pulling crustal rocks due to tensile forces is a slow process. The rocks continue to be stretched so long as the tensile forces do not exceed elasticity. They are broken, and broken blocks try immediately to occupy their previous positions so that they may adjust themselves. All these processes occur so rapidly so that causes crustal disturbances in the form of earthquakes. Example, activization of faults along San Andreas Fault in the southwestern United States of America, very close to California. In fact, that earthquake of 1906 belongs to this. So also this fault adjustment often takes place on the land also. In Asia, in our own country, in Maharashtra, there is a big kind of fault and earthquake happened in 1963, and that is attributed to elastic rebound phenomenon. And also Buzz earthquake of 2001 also happened mainly due to the activization of faults. Now let me come to human-induced earthquakes. Construction of huge reservoirs for irrigation and to generate hydroelectricity is one of the human-induced reasons for the cause of the earthquakes. In fact, their impounding of sudden huge quantity of water leads to disequilibrium in substrata and activization of faults beneath. There are many examples across the world for reservoir-induced earthquakes. Human activities like increased exploitation of groundwater, in fact, for increasing urbanization. Our towns and cities need more water. We draw a lot of water from underground water. So deep underground water mining and also mining of the minerals, particularly oil, coal and natural gas, etc. And also during the construction of activities, dynamites used for blasting, particularly nuclear explosion, etc. have induced medium to minor earthquakes. The distribution of earthquakes is quite widespread. There are million minor shocks a year. Most of the shocks are minor, and about 20 or an average a year occur in two zones. If you look into the figure number 5, which is nothing but a world map showing the distribution of earthquakes, you can see clearly some belts. The first one, the Pacific Belt or the Pacific Zone, which is also known as Circum-Pacific Belt, constituting western coastal and Rocky Mountains and Andes Mountain region of North America, South America respectively. From Bering Strait to New Zealand via Japan, Philippines is the other stretch of the Pacific Rim experiences major shocks frequently. The second zone, running from North Africa through southern Europe, Greece, Italy, etc., and Asia via Turkey, Iran, Iraq, and Afghanistan via Himalayan belts of northern India via East Indies, it links Pacific zones. While Pacific zone accounts for about 80% of the world's major earthquakes, mid-continent belt from North Africa to Southeast Asia accounts for about 15% of the world's major earthquakes. Due to reasons already discussed, which constitutes both natural and man-made causes, about 5% of the earthquakes are distributed other than these two major belts, namely Circum-Pacific Belt and also Mid-Continental Belt. This includes earthquakes of peninsular India, maybe Koina earthquake since 1963, or Usmanabad Latur earthquake in 1993, and recent Buz earthquake in 2001. Though major older blocks of the earth like our peninsular India, as geologically they too have some faults, their reactivization along with anthropogenic activities just discussed will induce earthquakes. But when is the question, which earthquake seismologists are still engaged in research. Tsunamis are sea waves caused by the rapid rise of sea floor during an earthquake. In an open sea, tsunami waves often run for hundreds of kilometers long, may pass unnoticed. When they reach the continental shelf close to the land, water piles up to heights of 12 to 15 meters. They have enormous power to take away whatever comes from the coast. We can recall the worst tsunamis which struck our Andaman and Nicobar Islands and southeast coast of India during December 2007. Many earthquakes occur in coastal regions under the ocean floor, resulting in sudden shift in the level of the sea belt. Huge waves of tsunamis are created by the water displacement, and their effect may be felt for hundreds of kilometers in the open ocean. These waves are hardly noticeable and make no impression on passing ships. As the waves near the shore and reaches shallow water, however, it gets larger, travels at a great speed. The tidal waves may surge for the continental shelf around. However, the water piles up while continuing to move at a great speed. Narrow coastal areas will have huge surge of waves. Water and consequent tsunamis bring damage to life and property. Tsunamis can affect a region far removed from the source of earthquake. People have been drowned in Hawaii as a result of an earthquake which happened in Aleutian Islands, some 3,000 kilometers away in the Pacific Ocean. Tsunamis, billions of worth of property got washed away or got damaged in the Southeast Asian countries, including India. Lastly, earthquake as an environmental hazard. Apart from the immediate effects like collapse of the buildings, an earthquake can create an havoc by burying settlements under landslides, destroying coastal regions through the coastal waves. Worst effects often occur in urban areas by fires, which happen by damaged cables, gas mines and petrol storage tanks. It is these secondary effects that most often cause the appalling loss of life associated with an earthquake. An historical study of the record of earthquakes will provide such losses of life and property due to these uncontrollable forces of nature and destruction of sewages, sewage systems and water pipes and supply systems also leads to epidemics in the disaster-struck areas. However, some preparedness with science and technology and management principles of earthquakes, like understanding the earthquake-prone regions, say in areas like Japan, USA, etc., at least some lives and properties can be saved. Example, seismic sea wave warning systems which are in place in Pacific Ocean by USA and Japan are helping early warnings of tsunamis. After the recent tsunamis, even in India, India is engaged in building such devices related to earthquakes and tsunamis. Now, with this we have come to the end of the earthquakes. Now, so far you understood that how earthquakes is nothing but the tremor of the earth crust, which may be due to volcanic activity or by other endogenic forces, maybe crustal fault adjustment and things like that. And these kind of tremors create three different waves from the epicenter, which is just having another point called focus, and you have seen P waves are very powerful waves. S waves come second, but they cannot pass through the liquid part of the earthquakes, whereas last to come are the L waves, which are the surface waves, bring a lot of damage to the life and property. Earthquakes can be measured with the help of two scales, namely one is the Richter scale, the other one is the Mecheli scale. The first one measures the magnitude of the earthquake, that means the force or the power of the earthquake, whereas the second one is relative and it shows the intensity, kind of damage, visible damage happened because of the earthquake. And now in world, when you look at their distribution, you have two important belts. One is the circumpacific belt, the other one is mid-continental belt, and here and there earthquakes are also happen because of the activization of faults and all that. Now around the world, particularly USA and Japan, along with New Zealand, they have made remarkable progress in the study of the earthquakes, and they have early warning system, particularly regarding the subterranean earthquakes which happen and bring tsunami waves, sea waves. And India also has two research institutes, namely Wadia Institute of Himalayan Geology at Dehradun. The other one is NGRI at Hyderabad. Even India is trying to understand phenomenon of earthquake as well as its distribution and also tsunamis. Thank you very much.